Okay, hello students, back for another lecture, continuing in 9A the mole, and we left off with calculating the molar mass for aluminum sulfate, and we said the answer should be 342.2 grams of aluminum sulfate. Next, we're going to look at types of formulas, so make sure you're writing this in your notes. Okay, so there's a structural formula. It shows types of atoms, how many of each atom, and the chemical bonds that are present. And so a structural, think of like a structure, a building, where you actually see the bonds. So it's like a structure, okay? So I can clearly see how many of each atom, 2 hydrogen, 1 oxygen, and I can see the chemical bonds, which are 2 single bonds in a water. It shows types of atoms, how many of each atom, chemical bonds. Okay, this is structural. Then we have molecular. Types of atoms, you'll see types of atoms and how many of each atom. You will not see the bonds or structures. So H2O is a molecular formula. And then we have empirical formula. What elements are present, so it'll tell you what elements are there, and the lowest whole number ratio of the atoms. So for instance, we have a compound C2H4O2 and C4H8O4. Both of these, like this is only a double of these, but it's a different compound. But if I were to reduce the 2,4,2 down to the lowest ratio, I'd say this could reduce to a 1, this could reduce to a 2, and this could reduce to a 1. So 1, 2, 1. Same thing here. What can I reduce it? By 2, right? Dividing by 2. 2, actually, this would be 4. 4 into 4 is 1. 4 into 8 is 2. And then 4 into 4 is 1. So 1, 2, 1. Both of them have the same empirical formula. So when we have the 1-to-1 ratio, we can't reduce this any further. So we could have different compounds, but their empirical formula reduced to the same empirical formula. Okay, percent composition. It shows what percent of a compound's total mass comes from each element. So if we were looking at the composition of water, we know water is H2O, and we can see most of water is made up of oxygen, even though there's only one. The hydrogen compared to the oxygen, the mass ratio is much different and much smaller. As a general equation, like when you get a test back and you got a 50 out of 60 points, right? What do you do to figure out your grade? You say, I'm going to take my 50 points and divide it by the 60 points total that I could have had, and then I would times it by 100, and that would give you a grade percent. So percent composition, we do this all the time. Think of your grades, right? Okay, so you take the part of a compound, each individual element, and then you do the mass of the whole compound. And so you would do this individually for each one. For instance, for water, H2O, the mass of water, if we have one hydrogen is 1.008 grams on your periodic chart, but there are 2 hydrogen, so we multiplied this by 2 and we have 2.016 grams. And for here we only have 1 oxygen, and 1 oxygen is 16 grams on your periodic chart. So if we add these up, it gives us a total of 18.02. So we're looking at part. We would take the part of hydrogen, the 2.016, divide it by the whole of the water, 18.02 grams, times 100 gives us a percent that hydrogen is. Do the same thing for oxygen, 16 divided by the 18.02 grams total times 100, it would give us a percent. Okay, so you're dividing part hydrogen divided by the whole of water gives us this 0.1119, and we multiply by 100, which moves the decimal point into the place for percentage, 11.19%. So out of 100%, 11.19% is hydrogen. And we do the same thing for oxygen. 16 divided by 18.02, we come up with 0.8879, times it by 100, moves it into a percent, 88.79. If you add these up, they roughly should be very, very close to 100%, if not 100%. They're actually just a little bit off. And again, it's because the way we're rounding, like these could have had numbers so much further. And so since we rounded, it actually changes it a little bit. But as long as you're very close to 100, that you can figure these out. Now, if you have these are only 2, right? So you're only figuring out 2. If you know it's out of 100, all you got to do is figure out 1. Figure out hydrogen, 11.19%, and then you could subtract that from 100, and that would automatically give you the oxygen. Okay, so if you only have 2 of these elements, figure out 1 and then subtract from 100, because the percent is out of 100. Okay, so here is the next video. I want you to watch this. This actually says for Tuesday. We're not watching it Tuesday. This is actually for Wednesday, right? Okay, so you're going to watch this today, Wednesday. Go ahead and pause my PowerPoint, and please go watch this video. It's actually very short. It's only a couple minutes, and it'll give you another explanation on percent composition. Okay, and I also want you to watch video 2, which again, it's in lesson plans under 415 Wednesday, because I initially thought we were going to have this for Tuesday, but we do not. It's Wednesday. So April 15th, watch this. So you should have just watched 2 videos by her, part 1 and part 2, and they're only a couple minutes each, so not too long. So when you're done with that, come back to my video and finish it. Okay. Okay, so we're back to 9.5% composition. Shows what percent of a compound's total mass comes from each element. So we looked at the water example. In your book, there's a problem, 230 problem. I believe it should be on your homework, not your homework, your 9A notes, okay? A laboratory analysis of a 30-gram sample of aluminum sulfate showed that it contained 4.731 grams of aluminum, 8.436 grams of sulfur, and 16.833 grams of oxygen. Okay, so we've got to find out what is the percentage. Now, instead of out of 100%, right, this is actually giving us a 30-gram sample. Okay, so we're going to use this as our whole instead of 100% or whatever it would be as far as individually. Okay, you can see that this says it's breaks up each part into grams, and it gives us that ratio out of the 30 grams. Okay, so if you added these up, it'd go into 30, where normally these would be roughly equaling up to close to 100%. Okay, so we are going to analyze a 30-gram sample. Okay, so what is the percent composition of each element? So we are looking at part divided by the whole. So you're taking part of aluminum divided by the grams of the whole sample times by 100, okay? And then you're going to do that for sulfur also, 8.436 grams divided by 30 grams times 100 gives you a second percentage, and then you would do it for the third one, okay? But again, there are 3 elements in this sample. So what you could do is you could actually calculate 2 of them, okay? And then, again, the percentage would be out of 100%, okay? And whatever's left over, you could put for oxygen, or just do the calculation 3 times. Okay, so part is grams of aluminum, sulfur, and oxygen. The whole is 30-gram sample. Okay, so we can do this a number of different ways. They gave us the 30 grams. If they don't give you the grams, like the water, we actually had to physically add these up. So if we had to add these up, we'd have to look up 2 aluminum, 3 sulfur, and 12 oxygen. Okay, so you can be given a sample, which is a little bit faster and easier because you can just put it here, or they may have you look up the actual grams and sample, where you would have to figure it out. Okay, and it says the answer is 15.77% aluminum, 28.12% sulfur, and 56.11% oxygen. Okay, so percent composition is not too difficult. Okay, we are going to go into empirical formulas, and this is for honors only. Honors only. Yay, honors. General chemistry, we're going to skip to 9.7 notes, which I believe are not in 9A. So by this time, I will be giving you another set of notes, all of you another set of notes, 9B, and it will continue with all the rest of the calculations and the notes and everything that we're doing. Okay, so I'm going to pause the video here because we do have a worksheet also that you can work on and start working on. That is in your activities, so look for that. I have an honors worksheet and a general chemistry worksheet, so make sure you get the correct worksheet. And I'm going to go ahead and continue this video with honors. Actually, I think I said I was going to quit, but I'm going to finish with honors empirical. So if you're general, you can stop the video right now and go work on your worksheet. If you are honors, you're going to continue looking at empirical formulas. Okay, so empirical formula, I will have a video for you. And so Melissa Maribel, so you can actually go watch that. And then I'm just going to go ahead and finish right here. I'll let you watch that because I don't want to get it too long and too much to do in one day for you. So I'm going to post this last video for Wednesday, and then I'm going to go ahead and stop the video and allow you to work on your worksheet. Okay, so watch this video, empirical formulas, and then you'll be done.